So yeah, I'm going to be talking about advanced serverless applications at the New York Times. I really wish I'd rename this. It's going to be partially about advanced uses of serverless at the Times, but also we're going to cover almost the psychology around serverless and the things that we've had to overcome in order to implement it successfully at the Times. So a little bit about me. I'm actually from Philly. I have a CS degree from Drexel. I joined the Times right out of college. I was actually hired as a Python programmer, and as soon as I joined the Times on the personalization team, my boss was like, hey, you know, this Golang thing seems to be like taken off. Why don't you just like start rewriting all of our APIs in Go? So that's basically what I spent the first year doing. I rewrote a PHP app, a Python app, even like a Node app that they had just running around. I rewrote them all into Go. And then in 2016, I had the opportunity to join the games team. So the games team is something that surprises a lot of people that we have one. So we handle the Crossword and several other things, but the Crossword is our bread and butter. So I've been officially a member of the games team since 2016. But more recently, I've actually started floating around the company and helping other teams either upgrade their infrastructure or launch a new product or, say, get ready for the elections, making sure that their systems can scale to handle election-level traffic. And then I also sit on the architecture review board. This board is responsible for essentially reading and reviewing all of the RFCs that teams around the company will write when they're proposing either a new project or a new technology or a new way of doing things. They'll write an RFC about it, they'll submit it to the board, we'll bring them in for office hours, we'll talk about it, we'll discuss it, we'll give our thoughts, and then we'll eventually review it. So the New York Times Crossword is actually really successful. It's a really big business, and I submitted the slides for this presentation just a few hours ago, and I did that because these slides have some information that I was legally not allowed to say until right now because the Times released their quarterly earnings report this morning. So we have actually reached 500,000 paying New York Times Crossword subscribers. To put this in context, these are people who are paying extra money to play the crossword. And the LA Times only has 150,000 digital subscribers, so that's a really big number. I've also been sitting on the parenting team. The parenting team just launched parenting.newyorktimes.com this morning. Really happy to have been a part of that. This is a site where you can go and get really high-quality content and evidence-based research on being a parent or expecting to be a parent, or even just like dealing with parents. So in 2017, our CTO, Nick Rockwell, he got up at Velocity Conference in New York City, and he gave a presentation, and he posed this question. It was basically the thesis of his talk, which was, what is serverless, and what if it's real? Like, what if it's a real thing? What if the hype is actually to be believed? And then a few days later, he followed it up with this blog post. It's actually linked right here, titled The Futile Resistance to Serverless. And it did not go over well. It did not go over well at all. In that blog post, he said, I stood up at this conference and I argued that serverless architectures are a huge innovation, will take over. Everyone was just scared. Why is everyone messing with containers? It's stupid, and this was not very well received. And he followed it with, however, I stand by my position. Some of the background to this was when Nick Rockwell joined the Times, he basically said, we're shutting down our data centers, period. Like, we're not renewing the lease. The New York Times had 4 different data centers in a bunch of different places. One of them was actually in our office in Times Square on the 12th floor. Talk about expensive real estate. So he was like, yeah, we're getting rid of all this. We're going to the cloud. And around the same time, I joined the games team in 2016. And one of our biggest projects was, we were already in the cloud. We're in AWS, but we were actually migrating it from AWS to GCP, specifically to Google App Engine. And it was just me and another engineer, just 2 guys, migrating this huge LAMP-style monolith in AWS over to a microservices architecture in GCP. And it was a huge success, so I think that was kind of in the back of his mind while he was saying, like, wow, we have these 2 engineers who can use these tools very successfully, And that's compared to maybe some other teams we have that have 10, 15, 20 engineers who are just kind of struggling with other tools. I actually stole this slide directly from his presentation. He kind of described serverless in the things that it is not. I think a lot of people get hung up on what serverless is. So I think it's really good, really useful to see like what it's not. So serverless is not functions. That's an implementation detail. They're not events. Reactive computing is great, but that's not really what we're talking about. And he actually stole these from a guy named Oren Teich, he was the COO of Heroku. Now he's a product manager at Google. Serverless does not mean statelessness. And serverless does not necessarily mean simple. You can actually build really complex with serverless systems. The other thing I wanted to throw in here is that serverless also does not mean Lambda. I know a lot of people work in AWS. AWS is great, and Lambda is kind of their like serverless offering. So a lot of times when people talk about serverless, they're usually just talking about Lambda. But that's just a platform-specific implementation. So I stole this from Google's website. It's kind of like the GCP hosting spectrum, where on this end you have completely managed by Google, and on this end you have completely managed by yourself. The New York Times generally falls right in the middle. A lot of teams are moving to the cloud, picked up Kubernetes engine, or GKE, and me and some other teams moved to App Engine. The one thing I want to call out here is that if you follow Google Next this year, they announced this new thing called Cloud Run. It's supposed to be the future of serverless. The reality of this is that Cloud Run and App Engine are essentially the exact same thing. They run the same data centers. It's the same infrastructure. It's gvisor underneath. It used to be that in Cloud Run, you basically hand them a Docker container and just say, run this for me. App Engine, you used to not be able to do that. You'd have to use something called App Engine Flex, which wasn't quite as good as App Engine Standard. But now, with App Engine, the new generation of App Engine Standard, you either just say, here, Google, here's my code, run this, or Google, here's a container, run that. So they're essentially the same thing. Another fun fact is that Cloud Run and App Engine, they actually run in Google's search infrastructure. So what is Google Cloud and what is Google, just Google, are two different infrastructures. But App Engine, because it's much older, it's kind of a, Google describes it as serverless before serverless was a thing, was running in their search infrastructure. And that's kind of like the explanation for why App Engine had some of the limitations that it did. You could only use certain APIs, you can only use certain libraries. That was because they didn't want you mucking with their search infrastructure underneath. So the Times, a lot of teams moved to GKE. The Times really bought into the idea that, we've got this new thing called Kubernetes. Kubernetes is the future. Kubernetes is going to make it really easy for individual teams to run and manage their own infrastructure and their own applications. I know that wasn't quite what the pitch of Kubernetes originally was, but that's what they kind of bought into. And what they found out was that a lot of teams, especially when the engineers are more junior and the teams are a bit smaller, and the Times doesn't really have an infrastructure team to lean back on anymore, they had a lot of trouble managing Kubernetes or managing GKE themselves. They ended up making a lot of mistakes. And a lot of these mistakes became clear during election readiness when teams would say, like, oh, we've enabled auto-scaling for pods. Like, all right, well, what happens when you run out of cluster? Well, we've enabled auto-scaling for a cluster. It's like, well, why? Then we load test it and it doesn't work. So why is that? So there's a lot of misconfiguration there. So our CTO has this quote, which I really like. It just means that serverless, for me, means any platform that provides utility while completely abstracting scaling and reliability. And it's a pretty broad definition. He even calls out, it could be App Engine, it could be functions, it could be your CDN that you're probably not managing yourself. It could be your fully managed database underneath. So a lot of things could be serverless without, some of the definitions that other people throw around. It could also, it could also mean Lambda as well, that's still used in the company. I do want to go over Cloud Functions real quick. We do use Cloud Functions for a couple different things. There are some use cases where Cloud Functions are very useful and can do some things that, say, App Engine cannot. Great for actions around data entities. So if you have, say, like every time someone solves a crossword, we get an event. We can use a Cloud Function that could see that and say, all right, we've got a new game solved. Let's go back and let's re-aggregate all of this user's score data so they have up-to-date statistics when they reopen the app. Hiding API keys from the front end. So imagine you have a website that someone signs in, or rather someone signs up, and you want to send them a text message, and you want to integrate with a service like Twilio. Usually those services will have an API key associated with using them, but you don't want to ship that API key up with your web front end, so the web front end will just invoke a function. The function will have the API key in its memory. It can do that call for you. And then consuming push queues. When you create a Cloud Function, you can give it one of two types of triggers. You can give it an HTTP trigger, which is just like a normal web app, or you can give it a PubSub topic. Generally, if you're consuming from HTTP, you're usually building a web app, and we tend to say that you should stay away from that. If you're going to actually build a full-service web app, you should be using App Engine, which has a lot more tooling around it, rather than a Cloud Function. The when's a maybe, not use serverless. So this slide is based on a lot of arguments that I have within the Times. People say, this service needs access to a file system, which at one point in time was very true. In fact, the games team, we have a Kubernetes cluster. One of the things we use it for is when a new puzzle is uploaded by one of our editors, one of the things that happen is we actually use that puzzle metadata to generate a PDF so that people can actually download and print out the puzzle and do it by hand. In order to do that, so we take the puzzle data, we generate the PDF, but we have to compress it. We use a third-party command line script called GhostScript to do that. So we can just ship that into a container, put that in Kubernetes, so the puzzle comes in from PubSub, the PDF is generated, compressed, and then sent back over PubSub to actually be saved in our database. This isn't really true anymore, just because App Engine, the second generation of App Engine, you are not limited to not being able to access the file system. You can just do the same thing. You give it a Docker container with whatever the hell is in it, and then Google just runs it, no questions asked. This service needs to maintain state. This is a really popular one. Usually the question is, all right, so that's like an implementation detail. What state are you maintaining? Like, why does this need to maintain state? In one instance, I went to a team and I said, all right, you have this, this app that's running in GKE. Why is it there? They're like, oh, we need to maintain state. I go, okay, what state are you maintaining? I go, oh, we have an in-memory cache of some data. And I go, okay, why is this data in memory? Why isn't it in a database? And they go, oh, it is in a database, except we're also running Memcache in a different pod in this cluster, and the performance between our app and Memcache was really, really bad. So we decided to put an in-memory cache on top of our actual cache on top of our database. And I'm like, okay, well, maybe it just sounds like your infrastructure is not set up properly. You don't need this state. You just happen to be relying on it as a crutch because these other things aren't working. This app actually ended up rewriting, putting on App Engine. Memcache is already built in, and it works much, much better now. This service needs to be long-lived. This one I don't really have an argument for. Serverless generally means ephemeral, so you can't have a service that lives forever. I have a service that I run on GKE that pulls off of a pull queue. It's actually a publishing pipeline. It's looking for certain articles. Valid use case. And this one, I didn't even phrase it as a question. It's usually just like thrown right out there, which is vendor lock-in. We've heard that serverless is all about vendor lock-in. We don't want to be locked into any vendor. And it's really more of like an emotional thing than I think a really logical argument, mostly because of the fact that where your data lives tends to lock you in a lot more than where your code is deployed, especially these days when if all you have to do is give it a Docker container, you can run that thing anywhere. Back in the day when you had to use certain APIs, from Google is a little more true, but these days it really isn't. If you've ever done like big code migration like we did, making sure the data from your old system to your new system is properly replicated and in sync tends to be a much harder problem than rewriting your code to work in a different system. So this is just a quick primer about how we did it. So we have this big monolithic stack running in AWS. The first thing we did was we implemented this game's edge service and app engine as just a simple reverse proxy to just capture all of our traffic and send it to our old stack, while at the same time having a special system that was actually reading our data from our old MySQL cluster and replicating it to our new services in App Engine that would write it to our new data stores. The nice thing about this was it gave us a platform to see how these things actually handle all the traffic, and actually gave us much deeper insight into what the data actually looked at, because me and this other engineer had joined the team very recently. And we were not really PHP developers. We genuinely didn't know what a lot of the data looked like. A lot of it was compressed when it was saved to MySQL, so we couldn't actually see the structure of it. So once it's in here, you could say log it. You could log it, decode it, do whatever you needed to do, and actually see what's going on. And then over time, as you rewrite functionality in Go and deploy it to App Engine, you start migrating new endpoints over to the new stack rather than the old stack. And this is kind of what we came up with in the end, and it's still kind of how I picture it in my mind, where we have this one game's edge that proxies data to all of our subservices. This isn't something that is serverless specific. This is really just more of a microservices architecture. But generally, within the times when people start developing systems around microservices, it often tends to kind of look like this, where you have one service that's open to the internet, that's accepting traffic, and then it's just delegating requests to whatever subservice it needs to. And this is dead simple. Like the traffic handling is literally held by one giant switch statement that's inspecting the path. If it's stupid and it works, it's not stupid. And down here you see like our game's PDF generator that's running in GKE, reading off a PubSub from our admin. This is kind of what it really looks like in real life. This is a much newer diagram. I didn't do this. It's actually kind of more complicated than it needs to be, but you still have this kind of, one thing at the top proxying to all these other things. A lot of stuff is reading and writing to PubSub. We have a couple new databases since we launched. Now we have Cloud Spanner, we've got BigQuery, we've got services that handle different aspects of it. And over here we have our puzzle editors. This is Sam Mazursky and Joe Faliano. Joe Faliano does the mini every day. He writes the mini. Sam does spelling bee, and this is Deb, our crossword columnist. So this infrastructure, despite being very, very large and rather complex compared to most apps in the times, this is managed part-time at this point by 2 engineers, me and the other guy who originally migrated it. We're off in the company doing other things. So at any given time, this whole system has between 0 and 1 engineer actually looking at it, which just goes to show, like, when you set it up properly and you have trust in your system, you trust its ability to scale, you trust its ability to manage security and everything. You can just kind of have this very hands-off. We don't have a PagerDuty alert or anything. I've never been on call. We have a kind of a, no one's on call, so therefore everyone's on call kind of policy. And we just lean back on our Stackdriver alerts to let us know if anything is happening. So I sleep very well at night knowing that all this is working properly. And then since then, we've launched a couple new games. This is Spelling Bee. It's a little anagram game. But like our new infrastructure, unlike our old one, which was very opaque, very monolithic, it was very hard to deal with. So our new infrastructure, much easier to deal with. We can just integrate this into all of our other puzzles infrastructure and trust that this thing is not going to go down because it's leaning on the platform that we've already built. Same thing with Letterbox. This one we launched the second half of 2018. You just build little paths. And the goal is to use all of the letters in here by building words. So there's Molar making a path around the grid. Again, this is just like a high-level view of what it looks like. Um, the nice thing about this is that Edge depends on everything else. Nothing depends on Edge. And then generally, these services don't depend on each other at all. They don't call each other at all. Even the GitHub repos that these are housed in don't really import from each other at all, except for games puzzle, since that data is a little more general. And one of the great patterns that I wanted to point out was that you can actually do concurrent requests to different services and then combine the results. So this is our iOS app, the play page. So we've got some puzzle details. We've got some puzzle progress. I golded this particular Tuesday. Go me. It took me almost 4 hours, but whatever. So the nice thing about this is that when we load the play page, so we're going to be grabbing puzzle data, we're going to be grabbing progress data, we're going to be grabbing packs, all sorts of different things. So we make all these, and we're using Go, so we have concurrency. We can make all these different requests, grab all the responses, combine the results into one, this kind of play feed, and then return it back up to the client. This one is a little bit weirder. I wish I had time to update the graphic for this. It's pretty old. But a lot of times, if you have a divide and conquer kind of problem, serverless systems actually tend to be really useful for this. So I ran into this problem when I had to figure out how to bulk load terabytes of data that we had in data store into BigQuery so we could run analytics on it. Because when we went to data store, which is a document store key value type database, we lost the ability to run aggregate queries on all of our data. We have terabytes of data, so we wanted to move it. So I wrote a little App Engine service. So it has two endpoints, one to kick off a job. So you just say start, and it will figure out the keys of all of the data that you actually want to move. And it'll start publishing out all of those keys to PubSub, or any queuing system that you have. And I actually set up the system to not only be a publisher, but it's also a subscriber to this PubSub topic. So these keys will actually flow right back into the exact same service, hitting a different endpoint. An App Engine, the load balancer on it is going to say, oh my God, I've got all these requests coming in. I'm actually going to scale this entire service up to handle that load. And then these subsequent requests will do, they'll take the key, they'll grab the actual data, and then they'll save it to BigQuery. So just an interesting way of building your own MapReduce with a serverless system. And you don't have to worry about scaling this at all. It handles it for you. And one of the things that's really, really nice is that people complain about vendor lock-in and all this stuff, but when you kind of really buy into a system like this, you get a lot of things out of the box that you wouldn't if you were trying to manage it yourself. Like this, if you want everyone to be logged in with their Google account on this particular path and always use HTTPS, that's just a few lines of YAML. You don't have to worry about managing any certificates or anything. It's just built in for you. This is something that I really love. We use a lot. It comes with, when you launch a service, it comes with its own URL. It's on HTTPS by default, and you can actually call a specific service dot the project name. In fact, you can even call a version dot the service dot the project. So one really nice thing about this is that I can launch a new version of an application to production, migrate zero traffic to it, but I can hit it specifically myself to see if it returns the data that I want it to. And you get some built-in tools. This is your ability to actually migrate traffic back and forth between different versions. It doesn't clobber all of your code right away. You can actually launch a new version and roll back and forth between them at will. And you can split traffic. So you can do a canary deploy, give it, say, 10% of your traffic, 1 to 10% of your traffic, and see how it works. Generally, we don't do that. Since it's so simple to just roll back and forth and so quick, we generally don't do that. And the other nice thing is that it'll actually boot up. It'll pre-warm instances to match the amount that exist on the previous version. So if you have 10 instances serving traffic, you launch a new one, it'll automatically bring it up to 10 instances before it migrates traffic in order to make sure that it's a seamless transition. And you get this is a little thing I just built myself. App Engine, you can actually send mail with it. So I actually have a little reminder service that it'll check data store to see if I have any reminders for that day. And if it does, it'll send me an email. This is really useful. Combined request and application logging. I mean, if you all are out there like tailing your logs and grepping through them, you are missing out. So there's just the whole Stackdriver console where you can go and you see the URL that was hit, and then in the context of this request, you see all the logs that happened within that request, which is really nice for debugging. Monitoring, you can just set up different log metrics or built-in metrics that come with the service. Yeah, Stackdriver comes out of the box. The other really nice thing is that when you buy into this, you get distributed tracing across your entire stack. So if I make a request to our Sudoku page, it's going to go through NewYorkTimes.com. It's going to go to the Edge service. Your Edge service is going to make an HTTP request to our Puzzles service. Puzzle service is going to receive the request. It's going to do 3 memcache gets for the 3 puzzles that it wants, and then it's going to return up the stack within about 60 milliseconds. So you literally get distributed tracing across your entire stack. And then you can just do local testing. So I can actually boot up these services locally. I can boot up more than one. So here I'm booting up Edge and Puzzles. You see the ones that are running at 8080, the other one's running at 8081. And I can just make HTTP requests. It has a full data store emulator underneath, so I can actually treat this like a real service. And this was something that was a little surprising. It's kind of true in App Engine where the services, or the instances rather, they are not one-off. So the instance will boot up, it'll handle a certain number of requests, and then it'll go away eventually. And even if you have like a Cloud Function that's invoked for every single event that's driving it, we realized that memory management isn't quite as important as it used to be. And we found this out when we took code that was running in App Engine, and we copied it and we pasted it into another service that was running on GKE that was doing something else. And we noticed that instance had a very small memory leak. So over time, since that instance was surviving for so long, we could actually see the memory going up and up. So we actually had to button down and find this memory leak. In the code, it had been there forever. We just never noticed it because the instance it was running on was never lasted long enough for it to actually become a problem. So this is the New York Times traffic over the course of a week. This tall spike in the middle is a Monday. Mondays are an easier puzzle, so a lot of people, or it's the easiest daily size puzzle, so a lot of people do it. And these are the weekends. So 10 p.m. every night, the new puzzle goes out. We actually send a push notification to people's apps, say, hey, it's 10 p.m., new puzzle's available, come download it. So that's what these spikes are. These are the weekends. These are a little bit different. You actually see there's 2 spikes, and that's because the puzzle on the weekends is released at 6 p.m. instead of 10 p.m. So you have a first rush of people who want to do it at 6 p.m., and then you have people who are habituated so much of doing it at 10 p.m. they actually come back at 10 p.m. and do it again. We call this a cat pattern. So the New York Times in general has very spiky traffic. It's not quite as regular as the Times crossword. We know when we're sending out a push notification. We know when the new puzzle is available, and we know when people are going to come. But the Times sends out, we deal with the news. The Times has breaking news alerts. Sometimes these breaking news alerts are really, really popular things, usually because they're horrible, but they drive a lot of traffic. So it's a really big problem that a lot of other sites may just not have. They have this very kind of smooth sine wave that goes up and down throughout the day, but Times traffic tends to be very spiky. So now serverless tends to equal fast scaling, but more importantly, what it really means is scaling on demand. If you can predict when something is going to happen, not the event, but we can predict when the news alert's going out, we can preemptively scale for these things. And this is one of the reasons why our old infrastructure, this Lambda stack on AWS was so expensive. It was because it was so hard to scale this thing that they had to keep it scaled for maximum traffic at all times. So that in order to handle this traffic, it had to be scaled to handle this traffic. And this is a jump between like a few hundred requests a second to sometimes 10,000 requests a second within 1 or 2 seconds. There are a few gotchas when it comes to serverless. This is something I've run into when working with teams that have Node on App Engine, or I don't have any direct experience with it, but say Java on App Engine, where your language choice becomes more important because that really affects how long or slow your cold starts are. And if you want to be able to scale really quickly in order to handle dramatic traffic increases, the choice of language becomes more important. So a Node app, I was just looking the other day, can take between 3 and 5 seconds to actually start and be able to receive traffic, whereas Go, which is more lightweight and slightly faster language in some cases, will only take usually less than 100 milliseconds. So when you need to boot up hundreds of instances at once, they're all available very, very quickly. The other thing, Google at one point changed how they charge for logging. So they're storing all these logs for you. And if you have a certain amount, they start charging you a lot of money. But they also give you the tools to filter and exclude logs. So for instance, we'll filter like 99% of our 200 responses that don't have any application logs associated with it. And the other thing is that, I wish I had a diagram for this. If you see a spike in traffic, App Engine's going to boot up all these instances to handle it. And then those instances, like even if the traffic goes back down, those instances are going to die off over time. So if you have hundreds of them, they will die off, but it'll be over the course of several hours as they gradually fall off. So you're paying for all these idle instances that are just hanging around. You can fix that by setting a max idle instances, which basically says, we may have, or you may have 200 idle instances hanging out, but we're only going to pay for, say, 5 of them. So the nice thing about the games team is that we can predict when our traffic is going to happen. So one of the really cool things about App Engine is that it can actually modify itself to scale itself. So, and it also has built-in crons. So at 9:55, we actually have a little cron that says, hey, it hits this all over, we have a bunch of crons that hit a bunch of our services and say, it's 9:55, I need you to set yourself to scale to 150 instances right now. So over the course of a few seconds, it'll scale all the way up. 10 p.m., our traffic spike hits. You actually see the idle instances, this blue area, will fall as those instances start being used and turn into active instances right here. And then, a few minutes later, the traffic spike is over. We actually hit it again and say, all right, good job. Scale yourself back down to just a few min-idle instances. And the last thing I want to cover is secret management. There are a couple different ways to handle secrets in the world. You can encrypt your secrets and check them into GitHub, which is wrong. You should not do that. Please don't do that. That's how secrets get committed in plain text to GitHub. The other option is to give them to your CI/CD pipeline and let that handle it. And a lot of teams do this, but we've actually developed a new way of handling secrets that I really like. And we open sourced a project called GCP Vault to do it. So all of our secrets for our teams and our applications are stored in Vault. So what all games applications will actually do is instead of shipping the secrets when you build your app, the app will actually wake up. When it wakes up, it'll actually reach out and grab all of its secrets from Vault, populate itself. Again, serverless does not necessarily mean statelessness. It can actually hang on to these secrets for the duration of the instance. And this has become super useful because this basically takes secret management away from the developers completely. You write them to Vault, and you never worry about them again. all you have to do is configure your app, say, hey, look here for your secrets. Which is really nice because if you wanted to rush out a new version of a project or a new version of a service from your command line for whatever reason, instead of going through the normal CI/CD pipeline, you'd have to remember to have all of those secrets stored locally on your laptop or read them all from Vault and actually attach them as environment variables when you launch this new instance from your laptop. So now you don't have to worry about that anymore. You just say, here, launch this instance. When the instance wakes up, it'll go and grab all the secrets for itself. That's it. Thank you very much.
Thank you, Darren. So we have time for questions.
Just a question about the last comments about secret management. So does having instances reach out for secrets increase the cold start time? Is that an issue for you?
The answer is yes, but we haven't found it to be a problem.
Okay.
And so the way App Engine handles warm-up requests or provisioning is that it'll literally send a request, a little GET request to a special /warmup endpoint. So if your application has that endpoint, that's where we'll do the secret fetch, and then App Engine will wait until that response returns with a 200 before it actually allows traffic to flow into it. So yes, it does to some extent affect it, but we haven't found an issue with it. In the back.
So from what you've discussed here today, it sounds like your definition of serverless is a lot broader than I walked in thinking it was. Mm-hmm. On the distinction between running something on, say, App Engine or Google Functions, have you noticed a cost difference?
So there will be a cost difference just because they're billed differently. With GCF, you're billed on, I guess, your compute time, and then with App Engine, you're actually billed on the number of requests that you have. As far as cost goes, it's not really something we haven't really experimented with one or the other and tried to compare them both, just because they're different enough services that App Engine has a lot of tools built in that Cloud Functions does not. We've never actually used it for a full web application.
Yeah, so it seems now you use GCP as your major cloud provider. How about you think about the vendor Lockin? For example, you use GCP service in future. If you migrate to other cloud, it may be super hard. Do you have any thoughts?
Well, like I said, we're not shipping our code just to Google anymore. We're actually building in a Docker container and running it on a serverless infrastructure. And with Cloud Run, you don't have to run it in, I'm going to call it the App Engine infrastructure. You can run Cloud Run Docker images in GKE as well. That's a feature that they have. So in terms of vendor lock-in, it's no more vendor locked in than normally running on GKE.
Two questions. One is whether Google Functions also changed their execution duration limit from 5 to 15 minutes. And the other was, did you guys consider using Lambda for your apps? And why not did you choose it?
So the first question, you're asking, did they or why did they? I'm not sure. So, but even if it is, so it has 15 minutes to respond to a request, right? App Engine, a little bit lower, has about 60 seconds, give or take, which is nice, right? It allows you to do whatever job you want that can last within 15 minutes. But generally, if you had a job that was going to last on the order of minutes, could you be sure that it's going to end within 15 minutes? It's not really a question of how long will it actually last. It's a question of, will this die at some point, or will this never die? I think that's the biggest distinction between, say, a pod in Kubernetes versus App Engine. Because in App Engine, I know it has to die at some point, whereas Kubernetes, it doesn't. So yeah, it's more flexible, but that's the distinction. What was the other question? Sorry.
So the criteria for choosing between Google Functions and Lambda?
Generally, the Times uses GCP, which is kind of true, kind of not true. We have, when we moved to the cloud, the directives were essentially move to GCP if you can, move to AWS if you have to. So there are teams using Lambdas, but a lot of times it's not that they wouldn't want to use Google's products. And I'm not here to compare Google and Amazon. Like, I'm just saying that these are the tools that we use. I do not get paid enough to make the decision to say whether or not we should use this. Sure, but again, App Engine generally does have a lot of tooling built in and features that Lambda doesn't have. Especially, Lambda for the longest time was node only, right? And recently announced support for Go. And I believe GCP functions are generally the same thing. So in that way, those things are inflexible. Whereas with App Engine now, you can just give it a Docker container. It doesn't care what language that you're writing in.
One last question.
Is there a difference something between serverless and have you used any third-party libraries that have licensing fees?
I'm not sure. Can you give me an example? I want to say no.
Did you use any other product with your serverless, any third-party libraries for executing your functions?
Third-party libraries, no, we do not. Generally, we either write it ourselves or lean on open source or open source the tools that we use.
Thank you.
I've got one quick question. How did you handle the authentication into Vault?
We use the service account to generate an identity token, which then we use to log into Vault.
Okay, so thank you very much, Darren. Let's give him an applause.